on predicting maize and soybean yield in an Acacia auriculiformis agroforestry system using APSIM next generation. Next slide, please. All right. Why agroforestry systems? Because it brings benefits for small growers or small farmers in the short term through the productivity of the agricultural crops, and in the longer term from the trees itself. The field trials in agroforestry system has limitation because usually we only have in the first few years after planting the trees, but the tree rotation itself can take from 5 to 20 years or more to be harvested. Then the other constraint is to maintain the consistent field trials condition. Therefore, we use the modeling of agroforestry system that will provide an opportunity to explore potential tree crops interaction while minimizing the needs for large-scale, long-term, and multifactorial experimental field trials. Next slide, please. Right. We choose APSIM next generation or APSIM next gens. Why? Because the APSIM itself, it's already provide the good response of agricultural crops to complex management scenarios. And the speed of the simulation process in APSIM is increasing up to now, much higher now. And the agroforestry system model, it consists of interconnected modules. So we have soil, crops, tree proxy, climate, and management modules. They communicate between independent modules and managed controlled by a simulation engine. So it's kind of playing games, but scientifically. Next slide, please. So the purpose of this research is, one, to validate that APSIM next-gen could reasonably model the tree effects on crop yield and soil moisture during the first tree cropping seasons, similar with the field trials. And the addition is we want to explore the potential effects of trees on crop yield in the trial from the 4th to the 8th cropping season or until the tree harvested. Next slide, please. Next slide. All right. The field trial was in Gunung Kidul, Yogyakarta Province, Indonesia. The soil type is the cracking black clay soil. We have 3 treatments: monoculture of acacia, monoculture of maize in the first 3 months of the rainy season, and followed by soybean. And then we have the agroforestry treatment. Next slide, please. The result of the trial, the first one is tree growth was not affected by the agricultural crops up to tree age 27 months. In the early cropping trial, the trees had no effect on crop productivity to the maize and soybean up to the 2nd cropping season. And during the 3 cropping season, water was not the limiting factor for the trees and the crop growth. Next slide. We set up the model using a beta version of the APSIM next-gen provided by Horsworth. And we also using the maize modules and a beta version of soybean module. This agroforestry model, we could not simulate tree growth dynamically yet, not now, but we have a tree proxy module, so we can input the characteristics of the trees into the model. Then, it's okay, we can continue to the next slide. The acacia crops model, we use the glycosidy maize agroforestry system model provided by Smatters. He guided me a lot while we are simulating this model. So we changed the zone, adapting into the research type in my module. So we simulate the model from 1 January 2016 to 25 April 2018. We have 3 cropping seasons, but the maize in the first cropping season, we not model because when we start the experiment, the maize already harvested. And we have 11 zones. Next slide, please. Yeah, so we have the 3 crop interface and we name it 0. And then we have several distance from the 3 crop interface up to 100 meters. And we also have where the 3 rows or the tree line, and under the tree we have the crops as well. We name it the negative one. So we evaluate the model performance that we set up using this parameters. So we have linear regression, MAE, and it's all automatically calculated by the DFSIM. Next slide, please. All right. So we want to explore how is the crop yield production after the field trial finish up to the trees is harvested up to a distance 100 meters from the tree crop interface. So we want to know how far away the potential competition zone from the tree crop interface. Next slide, please. Right. So we have the observed value here for soybean during the first for A, then the second and the third cropping season. Not very good, but not bad as well. So it's in the middle, moderately. Next slide. This one is for the maize for the second and the third cropping season. Next slide, please. All right. So we compare the observed and the predicted value from the model for maize and soybean in the third cropping season. So we have the R square for maize is 0.74 and for soybean is 0.51. Moderately predicted by the model. There is still room for improvement yet. Next slide, please. Okay, can go to the next slide. All right, beside the crop yield, we also want to know whether the EPSIM can simulate the soil water situation in the field trial. So this one is for the 0 to 10 centimeters soil depth. Next slide. And this one is for the 10 to 20 centimeters soil depth. And the third one is for, next slide, please, the 20 to 30 centimeters soil depth. Here we can see that, well, the R square is only 0.31, so it can be caused by the variety of soil type in the field trial. Then that is we only use one parameter, soil moisture. That's not enough yet to make a good model. Next slide, please. Yeah. But because water was not the limiting factor in this agroforestry system, so the not so good capacity of the model that we created using EPSIM was not really affecting the purpose of the study. All right. Next slide, please. Now we want to know whether the model that we set up can predict the result of crop productivity from the 4th to the 8th cropping season. In the soybean, we can see that from the interface into up to 10 meters in the 4th cropping season, there is still some yield, but only around 1 ton per hectare. And the competition zone, we can see here, from the 4th cropping season up to the 8th cropping season will increase as the distance, as the 3/8 increase. The same trend, next slide please, also happened in the maize. However, because maize needs sunlight more than the soybean, we can see that the competition zone will make maize unproductive at all, 0 ton per hectare. And again, the competition zone will increase from 10 meters from the tree crop interface to 40 or 45 meter from the tree crop interface in the 8th cropping season. Next slide, please. So this initial study demonstrated that the AppSim next-gen model was capable of simulating the effects of tree competition on crop yield in an acacia agroforestry system, and there is an open opportunity to vary the crop in the agroforestry system, not only maize and soybean. Then the simulation, the result of the simulation suggests that as the trees continue to grow, the trees will compete strongly in the competition zone with time. So the farmers or the grower need to select the agricultural crops that will be cultivated in the possibility of competition zone in the acacia agroforestry system. Especially the competition will be from the light competition as the 3/8 increase. The last slide, please. So because it's still prediction, we need to, the data, the result of the study need to be validated with real data, continuing monitoring of crop yields around 3 crop competition zones. And we would like to thanks to ASEAR for the funding for this research, then CSIRO, Tasmania Institute of Agriculture, Gajah Mada University, and Center for Forest Biotechnology and Tree Improvement in Yogyakarta. So the study is capable to be conducted because of the coordination between this organization. And thank you for my supervisors. Thank you.
Okay, thank you, Dr. Aram, for your very interesting presentation. And we still have about 5 minutes for you to present your paper, but you complete your presentation earlier and very efficient time management. So now, when you look at the papers presented by Dr. Aaron just now, is talking about the usage of AppSim, next generation, to evaluate the effectiveness of agroforestry system model, and in the conclusion. So there is what we call some significant result with regard to the management of intercropping, and we hope that using this system, the farmers can more productive in managing their intercrop, and we hope with this technology later on will increase the production of our agroforestry and also the timber forest plantation. So thank you, Dr. Ron, for the presentation. So now we are going to proceed with our last paper today, and we would like to invite Mr. Mark Blomberg the adjunct Senior Fellow in New Zealand School of Forestry, Tekura Nagahere, New Zealand. So he is presenting the using miniature plot to assess the effect of soil on the productivity of tropical plantation forest, a case study from Sabah, Malaysia. So to you, Dr. Mark.
Yeah, thank you, Datu. Can you hear me okay?
Yeah, very clear.
Very good, thank you. Okay, well, yeah, so thank you again, and thank you to the organizing committee for this conference for the chance to speak. Now, what I can see at the moment is that's what I want to see. And I will, hopefully I will be able to call the changes. So to begin, this is work that was done with my colleagues in Sabah, Agus Alwi and Yani Chaparudin. We also had help from two of my colleagues at the University of Canterbury in New Zealand, Lisa Wen and Elena Mokanova. What we were interested in is the productivity of soils and tropical plantation forests, and we have heard some very good speakers today on this topic, but we have a very unusual approach called miniature plots, and I want to talk about those miniature plots today. Okay, next slide, please. Yeah, this work could not have happened without a lot of support from Sabah Softwoods. So I'd like to thank Mr. Hatta, and also with help from the Borneo Forestry Cooperative, particularly Mr. David Bowden. Dr. Noreen at Sabah Forest Research Centre was invaluable with help with soil nutrients. One of my New Zealand colleagues, Dr. Mike Watt at Science Research, gave a lot of help with advice. Yes, the research was fully supported by Sabah Softwoods, and a lot of Sabah Softwoods people helped with the fieldwork, and also again to acknowledge the support of the Borneo Forestry Cooperative. Okay, next slide. A little bit of context. Really fast growth plantation forests are relatively new in Southeast Asia. Sure, they've been around for some decades, but compared with, say, plantation forestry in Europe or Australasia, possibly this form of forestry is a little bit younger. One of the key things that we are still therefore learning about is soils and productivity, and the effect that our soils and our sites have on the way the trees grow. So what we wanted to do was to take this new approach called miniature plots and apply it to three very important species, not just in Sarawak and Sabah, but also in Southeast Asia: Falcateria, Acacia mangium, and Eucalyptus pellita. The idea with miniature plots, they are small and very quick experiments, but we hope that the results will tell us about operational stands and give us the kind of information that would normally take much longer and a lot more resources to gain. Okay, next. So we did this work at near the Brumas camp of Sabah Softwoods in the southeast of Sabah. It's a tropical rainy climate. The rainfall about 2,300 millimeters per year, but quite variable. And depending on altitude, mean annual temperatures 25 to 27 Celsius. Next slide. Soils are orthic acrosols. They are formed on sedimentary rocks. That's the main geology in that part of Sabah. The soils are generally quite deep and actually not too bad. They are well drained. There are local areas of poor drainage where things can become a little bit wet. Okay, next slide. The three sites, Sabah Softwoods have been in business for a while. These sites were, in some cases, fourth rotation. The previous crop had been Acacia mangium in all three compartments that we used. What we then did was, for each of the 3 compartments, we found a ridge, a mid-slope, and a toe slope. Oh no, come back, please. Come back. Yes, thank you. So with 3 compartments and ridge, mid-slope, and toe slope, we therefore had 9 plots. Each plot, now we can change slides, please. Yes, next slide. Thank you. Now there is a lot of information here, so I will just try and be quick. You'll notice these plots are very small. They're only 9 meters by 8 meters in dimension. This is a very small plot with a lot going on. But key things to notice are that the top half is a subplot with FO, means no fertilizer. And then you notice the AM, FM, and EP, that's Acacia mangium, Falcateria, and Eucalyptus pellita. This layout is similar in the bottom 3 plots, except with F1, that means fertilized, and you have the same 3 species. We did soil sampling. Plot number 2 was the main soil sampling pit down to 90 centimeter. The other 2 plots were more for just collecting soil for soil nutrient sampling. Yeah, I think that's about it. We focused our soil sampling in that center strip so as to not disturb the soil where we were doing the tree planting. One final point, those trees are very close together. If you do the maths, they are only planted at a spacing of 0.5 meters. That is equivalent to 40,000 stems per hectare. There is a reason for that. With the trees that close, we're going to get very fast canopy closure in a very short time, and therefore we can estimate the productivity and growth of the site not long after canopy closure. Okay, next slide. So we started by measuring the seedlings in the trial monthly, and every month we would measure ground level diameter, not breast height, ground level, and the height, and we used the equation that you see there to calculate stem volume. Now, for each tree, we measured. We then did an average volume for each treatment, for each subplot, and used that average tree volume times 40,000 to convert to volume per hectare. Now, remember, we only measured up to 12 months. So to convert the volume per hectare into a mean annual increment, we were dividing by ages such as 0.5 of a year for 6 months. So what we did that, we were calculating a mean annual increment for each plot. What we found was the mean annual increment went up quite quickly, and then after 9 months, it stabilized. And it was at this point that the plots were fully occupied, the canopies were fully closed, and we considered, therefore, that at the age of 9 months, these plots were giving us a stable measurement of mean annual increment for the site. So that's what we chose as our, what we call response variable, the variable that we were interested in as a measurement of productivity. Okay, next slide. A lot of information here. Well, just to say that just to say what we were after was a set of physical soil properties that could be easily assessed by forestry technicians without specialized soil skills. Now, these things like drainage and consistency, in other words, how hard is the soil and how deep and how much rock, are all very important for growth. And the good thing is they can be easily assessed by our forestry technicians. So we chose these as our measures of soil physical properties, and we assessed these in each plot. Next slide, please. Now, at the same time, we took soil samples and had them analysed by Dr. Noreen. What I forgot to add in this is that not only did we measure soil chemistry, but we also got measurements of soil texture. In other words, how much clay, how much sand, and how much silt. And that, I'm sorry, that's not on the table, but we did measure them. So basically, we ended up with measures of total nitrogen, total carbon, total phosphorus, an available phosphorus measure, soil pH. And we think the ratio of carbon to nitrogen is important, so we calculated that too for each plot. Thank you. Next slide. Again, this looks like a lot of colors. All we wanted to say was that very often in soils, you find that if you measure one thing, it tells you a lot about the other. So for example, we find that if we have a measure of clay, then sand will be almost the opposite. The bigger the clay percent, the smaller the sand percentage, and that makes sense. But it also tells us things like with a lot of clay, the consistency becomes harder. And we know this, clay soils tend to be stronger and harder than a sandy soil. So doing this table helped us to say, well, we've got all these measurements. It's a lot of data. Which ones can we perhaps leave from our study? Because if we know about clay, we don't have to worry so much about sand or silt. And we found a few other interesting correlations that helped us to drop or reduce the number of variables that we were going to use in the study. Okay, next slide, please. So we made two statistical models, one to try and find explanations for the mean annual increment of our plots. In other words, how productive were they? Because we had put on fertilizer, we were also interested in fertilizer response. In other words, if we took a plot of Acacia mangium and we divided the mean annual increment of the acacia by the mean annual increment of the unfertilized acacia, what was the ratio? Of course, we expect this to be more than one. We expect that the fertilized trees will have a bigger mean annual increment than the unfertilized trees. And then we just took all of our measurements and used these as ways of potentially explaining the variation in mean annual increment that we were seeing. We also added location as possible explanation. Did the compartment itself just explain variation in productivity? Did species explain productivity variation? Did the slope position? And of course, what we expected was fertilizer treatment would. By the way, when I say complete luxury, we put on a very high amount of fertilizer. I think a previous speaker, perhaps Dr. Ecker, was talking about, or Daniel was talking about 40 kilograms of phosphate. We put on the equivalent of 1.4 tons of complete fertilizer per hectare. The reason we did this is we really wanted to make sure that we got a fertilizer response, and we did. Okay, next slide. So that's why these mean annual increments, anybody who has measured operational forests in Borneo will think, gee, this is very, very high. They are, but this is with a very high amount of fertilizer. And it's interesting that the three species were about as productive. In contrast, when we look at without fertilizer, the acacia still does okay, but the Falcateria and even the eucalyptus, not so much. So we can see that if we divide this number into this number, we get a fertilizer response. This number into this number, we get that. This number into this number, we get this. So for our other two species, Falcateria and eucalyptus, we're getting a strong fertilizer response. With acacia, it's there, not quite so much. Okay, next slide. Okay, lots of numbers here, but don't worry. This is just the models that we made that showed that mean annual increment was best explained by the following things that we measured. Yeah, available phosphate in the soil is important. The ratio of carbon, that's organic matter, to nitrogen in the soil is important. Fertilizer, we saw already, is very important because if we add fertilizer, we get an increase. But strangely, and this may be the most difficult thing to explain, our fertilizer response, it was modified by the carbon-nitrogen ratio. And I'll show a diagram shortly to make this clearer. With the fertilizer response, it was interesting. Sure, carbon-nitrogen ratio was important, but we also got location effects, such as the compartment, and we also got a species effect. In other words, well, we saw that. We saw that the Eucalyptus pellita and we saw that the Falcateria mollicana had different fertilizer responses. Okay, next line. No, next slide, sorry. Yes. Okay. So what we saw was if we look at mean annual increment on the left-hand side of the graph, we can see that the different plots in the F1 or fertilized treatment, they did vary, but they were generally the same no matter what the carbon-nitrogen ratio, which is the ratio on the bottom of the graph. But if we look at the unfertilized plots, we get a much different picture. There was a clear difference where as the carbon-nitrogen ratio increased for the unfertilized trees, productivity got better. Now, this is a very, very strange and unexpected result. The general rule is that carbon-nitrogen ratio is a measure of the nitrogen supplying power of the soil, which is very important for tree or crop growth. But strangely here, as the amount of carbon increased relative to nitrogen, and we would predict that MAI would go down, instead it went up. And we really need to think hard about this result. One potential reason was shown earlier by in Dr. Echo's work, where you can see that with multiple rotations of plantation forest, there is the potential to lose soil carbon. And it may be that what we are seeing here is a problem with the loss of organic matter from successive rotations of forest. Remember, we have 4 rotations on some of these sites. The nitrogen is not a problem. How many, sorry, Duncan?
5 minutes to go.
I think I can make it. Thank you.
Okay, thank you.
Yeah. But at the same time, because these sites have had multiple rotations of acacia, they also had the nitrogen fixing power to help this, to add nitrogen to the soil. So this is maybe one explanation. Next slide. Next slide. Yeah. Yeah, so these plots, they were cheap, they were simple, they were fast. They brought out some interesting results. It looks like Falcateria responds better to fertilizer than acacia and even better than the Eucalyptus pellita. We saw that available phosphate did have a positive effect on MAI, and this is similar to the results from Dr. Echo and Daniel earlier. We saw some alternative models suggested pH might be important. We're not so sure about that. Next slide. Okay, so these miniature plots, we still have some concerns, but because they are cheap and they are fast, they give the potential to rapidly assess your sites over a range of land and site types within the land that your country has. You know, so I think this is something that if you are interested in site productivity and you want to rapidly assess it, these miniature plots have potential. And I think that is probably what I would be leaving as the main recommendation. I think I've lost count. Do we have one more slide, or is that it? Can we just try? Conclusions, yeah. Okay. It was a small trial. We only had, no, go for it. Yes, brilliant, thank you. It was a small trial. We only had money and time to do 9 plots. You know, it would be worth the plantation growing nations of Southeast Asia if we had a large network of these miniature plots across a range of climates and soils. I personally believe we could start to build a very good picture of the drivers of productivity for our fast growth tree plantations in this region. And I'd encourage people to perhaps consider this idea seriously. Okay, that's it from me. Thank you to everybody for their attention.
Yeah, thank you, Mark, for the what we call interesting presentation and very meaningful data and analysis on your miniature plot on the productivity of 3 species that you mentioned here, Acacia and Falcateria and also Eucalyptus pellita. So when we look at the presentation by Mark, we still consider the management of site is very important, and the quality of soil to what we call encourage growth of the tree plantation, and of course application of fertilizer will give different response from the species that mentioned by Mark. So the Falcaria, Acacia mangum, and also Eucalyptus. So the Mark is also suggesting that need more research focusing on the role of soil carbon and carbon nitrogen ratio, and also to look into the usage of application of fertilizer in inducing the growth and also the yield of timber plantation. Yeah? So thank you very much, Mark, for the presentation. And now we come to the end of our session, plantation management for sustainable wood production. So we have 7 speakers presenting their case study, and we can conclude that the yield of forest plantation is very much depend on how we manage the site and how we understand the site and the application of certain technology like drone and also APSIM in what we call come up with the decision on how we can improve the production and the productivity of industrial forest project. So we look at the question raised by the participant. So we have one question for Dr. Chris. I think Dr. Chris, can you respond to this question?
I'll do my best. Can you hear me?
Yeah, yes.
Good. Okay. So the question was, I set up a situation where acacias and eucalypts were 50% better, double the productivity of some candidate indigenous species, and the consequences of that in terms of land use availability and the area required for plantation. So the question is it worthwhile to invest much more on the R&D of indigenous species, and what interventions could improve their growth and productivity? Well, you know, a lot of work has gone into researching candidate indigenous tree species for plantations over the last 40 years. Some, you go around Asia, you'll find everywhere there'll be candidates that the best candidate species, you know, in some cases will grow pretty close to the rate of the best acacia or eucalypt species. For example, Mangletia conifera in the mountains of northern Vietnam grows nearly as fast as Acacia mangum and is quite widely planted in monoculture there. The wood's a little bit more valuable than Acacia mangum wood, so you see quite a lot of small growers investing in that species. But I would say when you find an indigenous species that grows at a similar rate to acacias or eucalypts, great, but don't pretend that you're going to get great environmental benefits from planting an indigenous over an exotic species. You'll still have to manage it with weed control and inner monoculture and intensive management to get wood production. It's not the same. A monoculture indigenous species plantation is not the same as a natural biodiverse rainforest in Asia. Mm-hmm. Sure, it's worth investing more in the R&D for propagation of a whole range of native tree species so that we can re-establish natural forests with mixed species plantings, but we shouldn't then pretend that we're going to get a lot of wood production out of those. I think inevitably those will be reserved from production. They won't be cut down after 5 or 10 years and used for timber production like we do with these fast-growing monoculture plantations. So it's a matter of horses for courses, and not getting confused about the objectives of plantations. there was a little subsidiary question about polyploid acacia breeding, and I did, when my talk goes up, you'll see I've given a couple of paper citations where you can go and look at the results from polyploid acacia breeding in Vietnam, quite promising, and Dr. Ken will talk a bit more about that on day 3, I think. So thank you, that's the end of my answer.
I have one question for you, Chris.
Yes?
Yeah, we are talking about Acacia mangium and also eucalyptus, but now we have a new species coming in to our planters, which is Paulownia. So what do you think about it?
I don't know very much about Paulownia, but it seems a bit of a stretch to bring a Paulownia species from China down onto the equator when you've got year-round high temperatures and humidity. I can't see that it would be very well adapted. I can remember 25 years ago working in Sabah and Sarawak, and people were just about to start planting Paulownia on a big scale then. So I rather suspect if we come back in 20 years, we might find them just expecting to plant a lot of Paulownia again. But I think it's much better adapted to central and south central China than the lowland equatorial tropics. I could be wrong, but that's how I see it.
Okay, there's a claim that these Paulownia growing very fast.
Well, it could be growing very fast initially, but remember also it has very low wood density Paulownia, so it's only good for a limited range of applications. You wouldn't grow Paulownia to feed into a pulp and paper factory, for example.
All right. Any question from the participant? Since our presenter is still here. And another question for you, Chris. This is related to acacia, you know. We have a few species, families on acacia, mangium, and also superbark and corrosive kappa, you know. And when we do a study on processing of acacia, the issue is taking longer time to to achieve the MC, you know, because the moisture content when you cut the fresh acacia, the MC is about 50%. Yes. And if you're going to achieve for making of furniture, then it takes you about 28 days or maybe more. And they have some problem also on the air pocket in the sun timber of acacia. So do you have any comment on this?
We did look at this in Vietnam quite a bit, and they generally found that Acacia auriculaformis and the acacia hybrid between auriculaformis and mangium was less prone to defect and gave higher quality timber than acacia mangium. But I think it depends very much on the growing environment and then the environment where you dry and season the timber. But I do believe that acacia mangium grown in Borneo is quite suitable for making furniture. And as you probably know, quite a lot of acacia mangium was and may still be exported from Borneo to Vietnam, where it's processed into furniture.
Yeah, that is one of the issue when we process acacia, having the air pocket and also drying. It takes time to achieve the required MC. Yeah.
Of course, in Vietnam, they end up cutting it into quite small piece sizes and then reassembling as parquetry. So they're working with very small trees, diameters only 15, 18 centimeters for a saw log, and then they're reconstituting large panels for making furniture using parquetry techniques, and that works pretty well for them. They don't try to grow big sized logs. They harvest when they get up to 15, 20 centimeters diameter.
Okay, again, I offer to the participant any question from participants before we wrap up this session for our opening ceremony after this? Yeah. So if no takers, I would like to take this opportunity to congratulate and thank you to our speakers for being a very interesting presentation, and the knowledge shared is very meaningful to us, especially Sarawak, when we already focusing on planted forests for the next 5-10 years. So with that, on behalf of the organizing committee, again, thank you very much to all of you. We have 7 presenters this morning, and hope to see you soon in other conference. Okay, with that, thank you very much, and stay safe, please.
Thank you.
Yeah.
Yeah, thank you, Datu.
Thank you so much to all speakers, and thank you so much again to Dato' Haji Hashim for your contribution as a moderator in these sessions. Ladies and gentlemen, distinguished participants of the 3rd IUFRO Acacia Conference 2021, we will be having the launching ceremony that will be graced by the Right Honorable Chief Minister of Sarawak at 3 p.m. today. On behalf of the organizer, Forest Department Sarawak, Malaysia, we would like to invite and hope all of you attending via Zoom will join us together for the launching ceremony. Again, ladies and gentlemen, thank you very much on your valuable cooperations in this conference.